Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic, still in the sunshine. It's so exciting. Let's do some examples of proofs now that we have all of the proof rules that we need. I'm going to give just a couple of basic examples in this one. They're going to be kind of trivial and kind of boring, but then we'll move on to some of the more complex and complicated ones. So, I bet I didn't clean my whiteboard. I didn't. Shame on me. Two examples that we'll do in this video. The first one just involves questions of identity, and I want to show that you can prove reflexivity without using reflexivity if you have certain assumptions. So the first thing I'm going to prove is that if you assume that A equals B and that B equals C, then from this, I can prove A equals A without using reflexivity. Now, of course, if I did use reflexivity, it would be very easy. But this is just a nifty little proof that I can show that doesn't involve it. So our first assumption is we assume that A equals B, and then we assume that B equals C. So these are our two premises, our two assumptions. Then transitivity says if term 1 equals term 2, and term 2 equals term 3, well, term 1 equals term 3. So I can write down that A equals C, citing the transitivity and lines 1 and 2. Symmetry says if A equals C, so if term 1 equals term 2, then term 2 equals term 1. You could just change the order of them. So that means C equals A. Symmetry, line 3. But now, if term 1 equals term 2, and term 2 equals term 3, well, term 1 equals term 3. So I can do transitivity on lines 3 and 4, even though it doesn't actually have 3 distinct terms. Nothing in our rule says they had to be distinct. So from this, I can prove that A equals A. Transitivity, lines 3 and 4. There you go. Not terribly interesting, but sometimes it's fun to see, can you prove certain things? If I removed a rule, would I still be able to prove reflexivity? Yes, if I have the right kinds of assumptions to get me started. The next one is a little bit more interesting because it provides us with some kind of simple reasoning from universal statements down to specific statements about individual objects. So if we know that for all x, Rx implies Cx, and we know that A is R, then from this we should be able to prove that A is C. So first we write down our premises. For all x, Rx implies Cx, and Ra, so these are both assumptions. Now, anytime that you have a universal statement and you already have at least one constant in your premises or in other things that you've derived, for instance, A, do universal elimination. Put this into your repository of things you immediately do when you are doing a proof. Anytime that you see a universal statement and a constant, go ahead and do universal elimination. So what we do there is we erase the quantifier. So we would have just Rx equals Cx. You erase every occurrence of every free occurrence of the variable x and replace it with A. So that is universal elimination on line 1. I don't need to cite line 2, even though that was what gave me the idea to use A, because universal elimination can be done for any constant whatsoever at any time that we want, even if A hadn't already been in the proof. So it just cites the line of the universal statement we eliminated. But now we're basically back in propositional land. There's no quantifiers, there's no identity. We just have an atomic sentence and a conditional that has that atomic sentence as its antecedent. So we can do good old conditional elimination, lines 2 and 3, and there you have it. I have proved CA, which is what I wanted to prove. Oh, we could do something a little bit more interesting. Having proved that A is C, I could go ahead and do an existential introduction on that. And I can say, from the fact that I know that A is C, I know that something is C. So you can always, there's always other things that you can prove other than the examples that I'm giving. Just, it's an example to see how another rule is used. I hope you found that. Oh my, look at that sunshine. I might have to close the shade before I record my next videos. In any case, I hope you enjoyed these very simple examples. We'll start doing more complex ones with a lot more discussion in the next videos. We'll probably do, I don't know, 2 or 3, maybe even 4 more videos on proofs, because there's so much more that you can do with the predicate rules, and just seeing examples of it makes it easier to go on and start doing it yourself. In any case, take care. See you then. Cheers.